Oh, my shirt? It's the element of surprise. Get it? Because this element doesn't exist yet, and now it's here. Well, never mind. What about this letter? Dear Tim and Moby, what patterns exist on the periodic table, and how can I use these? From Robin. Patterns exist everywhere and can help us understand things, just as an atom's electrons rotate around its nucleus. Our planets of our solar system rotate around our sun. These patterns are very important for understanding the fundamentals of our universe. One way the periodic table is organized is in a grouping called periods. Periods organize the periodic table by increasing atomic number. Coincidentally, as the atomic number increases, so does the atomic mass. By this organization, it makes a pattern of grouping the elements into groups or families. These groups or families share similar properties of physical and chemical. For example, inert gases all have the same properties of being inreactive with most elements and stable by themselves. By having this organization and pattern, we can predict future elements that could be on the periodic table. For example, an element with an atomic number of 119 and atomic mass of 296. This element does not exist yet. For fun, let's call it timonium, of course, because that's my name. Timonium would be an alkali metal. Its physical properties would be silvery and soft. Some of its chemical properties would be high reactive, and oxygen has it corrode. This is where timonium would be placed on the periodic table. Timonium would be very reactive with this group on the periodic table, 17. This is because it would be able to complete its outer shell to make it a stable element. But you can find more than just one new element. There are many. For example, an element with an atomic number of 118 and an atomic mass of 295. Let's call it Mobion, because, well, he'll get jealous if it's not. Mobion would be a non-metal. It belongs to the inert gas family. It would be a gas, colorless, and odorless. Its properties would be it's non-reactive with most elements. It would do because it is stable by itself. This is where Mobion would be placed on the periodic table. As you can see, it would be a part of the inert gas family. It would be very unreactive. As you can see, there are many, many more elements that can exist on the periodic table due to these patterns. We'll do one more for the sake of time. An element with an atomic number of 120 and atomic mass of 297. This element we'll call Brainpop Ms. Brainpop Ms would be a metal. It would be an alkali earth metal to be exact. It'd be hard and be a good conductor of electricity. It'd be very reactive, and it would react with group 116 very, very well. As you can see here, this is where Brainpop Ms would be placed on the periodic table. A use of it maybe in magnets or such. So now I hope you can see how patterns can be used in real life and on the periodic table. These patterns can be used to create new elements just like Mobion, timonium, and Brainpop Ms. No, Moby, it's the element surprise, because now it's, you know what, whatever, enough for today.